7.2a disk and washer method. So what we're going to be doing now is, before we did area under a curve, we did top minus bottom and right minus left. And now we're going to rotate that area around an axis. So it's going to be coming off the page. All right. And so now it's going to go from two-dimensional space to what? Three-dimensional space. All right. And that's what we're going to be doing today. All right. All right, so this is as easy as finding an area of a circle. So how do I find an area of a circle? Pi r squared. Exactly. All right, so the area of a circle is pi r squared. And what we're going to be doing is we're going to be taking a bunch of areas of a circle and stacking them on top of one another. However, we're going to have a width of a circle, and we're going to call that width dx or dy, depending on what axes we have. So, if I have a dx width, right like that, and then I stack circles on top of each other, that's what we're doing when we're finding volume like this. All right? Because now, if I just have a line, that's one-dimensional space, right? Then we started doing area under a curve, and that's how much? Two-dimensional space. And then if I take an integral of an area, that's how many? That's three-dimensional space. All right? And that's essentially what's going on here. All right? So what I need to find is my radius, but I have a pi r squared going on. So I'd like you to write down your disk method right here. So the volume is given by pi, the integral from a to b of your radius squared. All right. And it's the same thing over here for y. We're just in terms of y or x, depending on what axes we're rotating about. Now, today we're going to be all in terms of x. All right. But essentially, I'm taking a radius and I'm going to rotate it about, and I'm going to be making circles that are stacked on top of each other. All right. That's essentially what's going on. All right, pretty good? All right, how do we find the area of a circle? Pi r squared. Put one into practice. So I need a reader, and Colin's going to read for us. Thank you so much for volunteering.
Calculate the volume V of the solid obtained by rotating the region under y equals x squared about the x-axis for 0 is less than or equal to x or less than or equal to 2.
All right, fantastic. So these are the pretty pictures drawn by a computer-aided software. All right. So CAD or SolidWorks or something like that did those kind of graphics. However, I want to write down how you would actually draw this. So, what is x squared? It's just a what? Just a parabola. So I have a parabola going like that. And then it's from 0 to 2. So I'm going to go from 0 to 2. And so this area underneath here, I'm going to rotate about the x-axis. So that's the kind of drawing I'd like you to have on your paper. However, what's happening is these radii are coming off the page and making kind of a cone-ish shape. All right? A funnel-ish shape. All right? It's solid because we don't have anything being subtracted out, but that's what it's doing right there. All right. So my radius is this portion right here, and I want to write out what my radius is. Well, what is my radius? It's just what? How do I get from here to here? That's my line function of x squared. All right. My radius is x squared. You following me? All right, so now I have an integral from what to what? It tells me it's from 0 to 2. And how do I find the area of a circle? Pi r squared. So that's why I have a pi out front. And then what's my radius? X squared. And what am I doing to it? I'm squaring it. And I have a width or respect to dx. All right. Remember doing our Riemann sums and dx basically went to 0? Remember doing that? And that was basically the area under the curve. It's the same thing. Now we're just going to rotate that area under the curve. All right, that's really what's happening. All right, so let's do it. So we still got a pi chilling out front. What is x squared squared? X to the fourth. All right, we multiply them. So then what's my antiderivative of x to the fourth? X to the fifth over 5. I still have a pi chilling out front. And then I'm going to go from 0 to 2. So now when we substitute in 2, what do we get? 2 to the power of 5 is 32. So now I have 32 fifths minus, substitute in 0, and I get 0. So now I have 32 pi over 5. And my units would actually be cubed because now we're talking about volume. All right? All right, let's do another one. Here we go. I need another reader. Thank you so much, Maddie, for volunteering. I appreciate it.
The equations of y equals the square root of 4 plus x when x is equal to 0 and y is equal to 0 to find the bounds of a plane region. Find the volume of the solid obtained by rotating the region about the x-axis.
All right, fantastic. So let's draw our parent functions. So what does a square root look like? What does it look like? Just like that. However, what happened to this parent function? Which way did it move? It moved left. So how far do I go left? I go 4 to the left. And so then I go just like so. And then I have x equals 0. What's another name for x equals 0? The y-axis. And y equals 0 is another name for the x-axis. So I'm bounded by that portion right there. All right. Remember when we were talking about the cows at Scapane? Did I talk to you about that? All right. So I have to keep everything in. That's what it's bounded by. All right. So now what's it rotating about? The x-axis. So that's the type of picture we should have there. All right. All right. You try it. Go. All right. So what's my big radius? What's my radius? Square root of 4 plus x. All right. And then my integral is going to go from what to what? What's it bounded by? Negative 4 to 0 because I'm in terms of x because I'm rotating about the x-axis. And then I have a pi chilling out front. And then I'd have square root of 4 plus x quantity squared dx. I personally would rewrite it. So now I have the integral of 4 plus x dx from negative 4 to 0. And now we're going to start anti-deriving. So what's my antiderivative of 4? 4x. I still have a pi chilling. And then what do I have? What's my antiderivative of x? X squared over 2. And I'm going to go from negative 4 to 0. So what do we substitute in first? 0. And what do we get? 0. Minus, now I'm going to substitute in what? Negative 4. So I end up with negative 16 and then plus 8. What would I highly suggest you do? All right, and we end up with 8 pi. So the volume of that shape would give me 8 pi units cubed, whatever my units are. Now, that shape would kind of look like a bullet. All right, that's the way I'd kind of think about it. All right, so when you rotate that, that would kind of look like a bullet. All right, pretty good? All right, let's keep. So now we're going to talk about the washer method. The washer method has holes in it. All right, so now, instead of a disc, they were completely solid. Now a washer literally has something taken out. But it's the same thing because now we have a big radius, which goes to the outer, and then we have a little radius, which we subtract out our little one. So it's really pi r squared minus pi r squared. Now, we factor out a pi. That's all that this formula did. Does everybody see how that worked? All right, so we really have pi, the integral from a to b, of our big radius squared minus our little radius squared. All right, so basically we're doing two disk methods. That's the washer method, basically. All right, so we have our big radius and we have our little radius. Again, what's the same going to be? It's always top minus bottom and right minus left. It's always that. So that's still very helpful for us. All right, so now we're subtracting out what we don't want. All right. So sometimes I have students do this. And I want to show you why this is totally wrong. Some students try to do this thing. What's wrong with that? I don't even want to foil that out at all.
Well, no, that's like wrong.
It's wrong why? Okay, I mean, we're both going to square things, but why is this one wrong?
Because it's the quantity squared.
It's the quantity squared instead of what? The individual radii squared. All right, so don't do that. All right, let's move. So here we go. I need another reader. Thank you so much, Danielle, for volunteering.
Find the volume of a solid 4,000 Kelvin, the region above y equals square root of x and y equals x squared y-axis.
About the x-axis. All right. So what does square root x look like? Show it. There it is. At least we got Renee going on. All right. And then what does x squared look like? Parabola. All right. So we got something going on like that. And so now we're going to take this area and we're going to rotate it about the x-axis. All right. So that's the way your picture should kind of look. All right. So eventually it will look kind of like that little teacup. I don't know what the heck it is. But anyway, that's what it would look like as we start rotating it. So what do we need to solve for? Our intersections, exactly. So we need to set them equal. All right. Now on this one, I personally like the guess and check method. So what would we have? What would be our intersections?
1 and 0.
X equals 0 and x equals 1. If we actually did it all the way through, if we started squaring things and all that jazz, we'd actually get 0, 1, and negative 1. However, negative 1's extraneous. Why is negative 1 extraneous? I can't square root of negative 1. We're not going imaginary number system. All right? All right, so now those are my two intercepts. So let's write out our big radius and our small radius. All right? So right now in the game, this is what I want you to do. Once we start getting really good at it, you might be able to just go at it. All right, so what's my big radius? So I'm taking my big radius the furthest away from my x-axis. So what's my big radius? Square root x. And then I'm going to subtract out my little radius. So what would be my little radius? X squared. All right. Can you see the yellow? Okay. All right. So now I'd have an integral from what to what? 0 to 1 with a what out front? Pi. And then I'd have my big radius of square root x. And what do I want to do to that? Squared. Why am I squaring it? Because it's the area of a circle. Because it's pi r squared. That's really why. All right. And then minus my little radius of x squared squared. All right. So square root x squared is really what? Just x. Then minus x to the fourth dx. All right, so now let's take an antiderivative. What is the antiderivative of x? X squared over 2 minus the antiderivative of x to the fourth is x to the fifth over 5, and I'm going to go from 0 to 1 with a pi chilling out front. So now I need to substitute in 1. So I still have a pi chilling, and then what? You get 1/2 minus 1/5 minus what? 0. All right. So now let's get some common denominators. All right. If it's a free response problem, they'll keep it like that. You can leave it like that if it's a free response problem. However, if it's multiple choice, which a lot of these kind of are, we need to keep going. So 1/2, what do we think of it as? 5/10. And then we think of this 1/5 as 2/10. So we subtract and we get 3/10. So it's 3 pi over 10 as my volume. All right, pretty good in the hood? All right. All right, let's do another one. Renee, this one looks like you. Oh, for sure, for sure.
Find the volume of the wedding ring obtained by rotating the region between the grass
All right, fantastic. Let's start drawing a picture. All right. What is this x squared plus 2? Parabola. Which way is it going? Up 2, and then it opens which way? Up. All right, so we're going up 2, and it opens up. That was terrible. All right, that was better. All right. And then this 4 minus x squared is what? Parabola going up how much? 4, but then it opens which way? Downward. All right. And then what are we doing? We're rotating it about the line y equals -3. So what kind of line is y equals -3? A horizontal line. All right. So I'm rotating it about the line y equals -3. So I'm taking this area bounded and I'm rotating it about that line. All right, so that's the type of picture that we should have. Now, I call this y equals something in x-axis. Is it the x-axis? No, but I call it an x-axis. However, it's shifted up and down because we're going to keep this in terms of what? X. All right, so that's why I call it an x-axis. Now, it was moved, though. All right, so what do we need to solve for? We need to solve for intersections. How do we do that? Set them equal. So now I have x squared plus 2 is equal to 4 minus x squared. So let's move some stuff around. I'd like to keep my x's positive, so I have 2. X squared is equal to 2. X squared is equal to 1. So x equals -1 and 1. All right. We also need to find our big radius and our small radius. So my big radius would be that one right there. It's the furthest away. So, again, it's always going to be top minus bottom or right minus left. So what's my top? 4 minus x squared. And then minus, what's my bottom? Okay. My big radius is this blue line, or this black line from my blues. So at my top is 4 minus x squared. I'm rotating about y equals -3. So the bottom would be what? -3. All right. So I'd have 4 minus x squared minus -3. That would be the length of my big radius. You following me? Now, I'm going to keep working with that. If I'm subtracting a negative, I'm really doing what? Adding. So my big radius would be 7 minus x squared. All right. Yesterday, I had a lot of people just say, add 3. Yes, we are adding 3, but I always want you to get in the habit of doing top minus bottom. Okay? All right. So now, what's my little radius? My little radius would be x squared plus 2, and then what? Minus a -3. All right. So then we're going to simplify that up, and we get what? X squared plus 5. All right. All right, so let's build our integral. So my integral would be from what to what? -1 to 1. What's chilling out front? Pi. Because why is a pi out there again? Because it's the area of a circle. All right, so what's my big radius? 7 minus x squared. And what am I doing to it? Squaring it. Minus, what's my little radius? X squared plus 5. And what am I doing to it? I'm squaring it. All right. All right. It's the 4-letter F word. What do we have to do? We have to FOIL. All right. There's no other way around it. We have to FOIL. I know. It kind of sucks. All right. So now we have the integral from -1 to 1 with a pi out front. So we're going to FOIL this 7 minus x squared. So what's my first? 7 times 7 is 49. Minus, what do my middle terms go to? All right, so minus 14x squared, and then what? Plus x to the 4th. Minus, now let's FOIL this one. So what do we get? X to the 4th, and then plus 10x squared, and then plus 25 with respect to x. What would I highly suggest you do right here? All right, so we start combining like terms. Something beautiful happens. What happens? The x to the fourth cancel, so that's awesome. So now how many x squareds do we have? Negative 24x squared. And what do my constants go to? 49 and negative 25 go to? 24. All right. So now we're going to take an antiderivative. So what is my antiderivative of negative 24x squared? Negative 8x cubed with a pi chilling out front. And then what's my antiderivative of 24? 24x from negative 1 to 1. All right, what do we substitute in now? 1. So when we substitute in 1, we end up with negative 8 plus 24. And then minus, now we substitute in negative 1, we get 8 minus 24. All right, I'd suggest distributing the negative, and what do we end up getting? It's not negative. 32 pi. That would be 16, that would be 16. We add those together. All right, I'm going to help set this up for you, and then you got it. All right. Julian's going to read for us.
Find the volume of the soil of the revolution by revolving the region bounded by y equals 1 minus x, y equals 0.
All right, let's draw our picture. So what is this line y equals 1 minus x? What is that? That's a line doing what? Going down. It's doing that right there. All right. Now it's bounded by what? Y equals 0 and x equals 0. So it's this area right here. And what am I rotating it about? Y equals negative 1. What would I call that? And x-axis. All right, go. All right, so we needed to find our intersection, so we set 1 minus x equal to 0. So I set my y's equal to each other. So now I know it's from 0 to 1. And then we find our big radius, so we do top minus bottom. So we have 1 minus x minus a negative 1. All right, so that can simplify to 2 minus x. So my little radius would be this portion right here. So that little radius would be 0 minus negative 1. So we're going to call that 1. So now I have the integral of big radius squared minus my little radius squared. And then what do we have to do? We need to FOIL it. All right, and once we FOIL and combine like terms, then we take an antiderivative. So we get 3x minus 2x squared. And then plus x cubed over 3. From 0 to 1, we substitute in and we get 4/3 pi. All right, pretty good? All right, here's your homework. Numbers 1 through 6, 15 through 18, 23, and 24.